So hello guys, today we are going to do a LeetCode question that goes by the name binary search. Yes. Today we are going to study about binary search. What is binary search? You must have heard about it, right? Must have heard about it in many places. What is binary search? Oh, it uses the time complexity of LogN. Many people have heard it, but people don't usually know how to use it, or they get stuck into this binary search because of the constraints, left, right pointers, so many stuff doing at the same time. So I am just about to clear all your confusions and about to tell you how does this binary search work? Why was this binary search introduced? Why was the linear search not enough? Why was a binary search like technique introduced? Why it is giving an edge over the standard linear search? Okay, so let us directly dive in to binary search. Okay, so first I'll tell you, for the people who don't know what a search is, what a linear search is, first I'll tell you, okay, suppose you are given some numbers. Basically, if you are given some numbers like this, 1, 2, 3, 4, and 5. Okay. And if I tell you, you have to look for the target, you have to look for the target 4. You have to look for the target 4. So what you will do? What you will do? Basically, some person would tell me that, so I would traverse this array starting from this index. So I would start from this index. Compare this value with my target. Is it equal? No, it is not equal. I'll just move forward. I come to this. I'll just compare it with my value. Is it equal? No, it is not equal. I'll just come to this. I compare it with my target 4. Is it equal? No. I'll compare this. Is it equal to my target? Yes. So I can return this index. I can simply return this index. Okay. I can simply return this index. So why is this not enough? Like, why is it not efficient? Why is it not efficient? Basically, if you just try to see, we are comparing all the indices. Basically, we are comparing all the indices. If you just try to look carefully, I'll just erase all of this for you. Okay. Yes. So what we are trying to do is we are comparing each of our indices. We are comparing our target with this, with this. And this is the index when we finally get our answer. So suppose in the worst case, if I am given a target 5, so starting from the first index, I'll have to traverse the whole array. And then only I'll get my answer. So as you can clearly see, what is the time complexity of my solution? Yes, as the name suggests, linear. So the time complexity is linear. That means O of n. Okay. O of n. Okay. So, okay. So is it efficient? Like if you are given with some higher constraints and you are doing it won't work out. Because if your time complexity is already n square or n cube, and you are trying to just find an element, and if you try to apply n again, time complexity will become n cube or n raised to power 4. Okay. So this wouldn't allow me to submit my solution because many constraints, many test cases can fail for this. Okay, so this is why this binary search, like a better searching technique, was just introduced. Okay, so how did the idea of binary search came? Okay, how did the idea of binary search came? Let us first try to read the problem statement. What does the problem statement say? Given an array of integer nums which is sorted in increasing order, an integer target. Write a function to search targeted nums. If target exists, then return its index, otherwise return -1. You must write an algorithm with of log and time complexity. Okay, we are given a very simple question. We are given a nums array. Okay, suppose 6, 5, sorry, okay, it's in sorted order. Okay, so it can be 10, 15, 17, 23, and then 31. So these can be my numbers, and I am given a target. The target can be like 17. Okay, so I have to find this target in the array. If this target exists, then I'll have to return its index, else I have to return -1, So how can I do it? How can I find this target? Okay, if I just try to do the linear search, okay, I'll just simply traverse through all the elements. I'll come to this, I'll come to this, I'll come to this. I finally come to this, and I'll return my index as 0, 1, 2, 3, 4. So I'll return my index as 2. But it is not efficient. Okay, so we are going to see an efficient mode of searching, a more efficient mode of searching. Okay, more efficient mode of searching. Okay, so suppose you are given a sorted array. Or you are given some books like this. This is basically book number 0. Okay, or this is basically book number 1. This is book number 2. This is book number 3. This is book number 4. This is book number 5, and this is book number 6. Okay, you come up to this, you come up to these books, you see these books, okay, and what you tell is, if some person asks you, if some person asks you to get the third book, okay, to get the third book. So how can you search for the third book? Either you can start iterating from this, and you search for this, you check its number, or what you can do is, if you know that the books are in sorted order, and there are six books, okay. So my third book would be somewhere in between. Okay. So what I'll try to do is, among these six, I'll just try to break it into two parts. I'll just randomly pick one book. Basically, if I pick this up, okay, I'll just check its number. What is that number? 4. Okay. And what I have to find out? I have to look for 3. So what I'll do is, okay, now I know that, okay, 4 I have, okay. So if I try to do the same thing again, I still don't know how many books I have in between. So what I'll do, I'll simply try to do the same thing again. I just divide the array again, because I know that as the books are sorted, so the books cannot be found on the right hand side. So I can easily find the books on the left hand side. There is a probability of finding the book on the left hand side. Why? Because as the books are sorted, so if 4 is coming here, 3 must probably come here. Okay, 3 must probably come here. So what I'll do is, I'll just split this array, and what I'll do is, I'll simply remove these books from my eyesight. Okay, from my eyesight, I'll just remove these books. Just see, I'm removing these books. Okay, so I'm left with only 3, 2, and 1 books. Okay, still I don't know what is my book that I have to choose for. So what I'll try to do is, I'll just again try to get the middle book. Okay, so that why I'm choosing the middle book? Because this can give me a reference, right? This can give me a reference of where I am. Okay, basically we can choose any random index, and then we can just see if we can just see on which side the book we are searching for lies. Okay, so if I choose the second index book, okay, I'll just take its index and I'll compare it with the book I want to find. I want to find the book 3, and I am currently on 2. So what I now know is, 2 is not my answer. 2 is surely not my answer. Okay, basically, if you are looking for a book, you have to check its number first. Now if you get the same number, you just return the book to the person that is asking you for the book. Okay, you just give the book to the person that is asking you for the book. Okay, so what I'll try to do is, I'll check it with my target that I have to want to find. So what I say is, 2 is less than 3. 2 is less than 3. Okay, so if I see on the number line everything is sorted 1, 2 and 3, I can easily see that 2 must not be lying on the left hand side, 3 must not be lying on the left hand side. Why? Because all the books on the left hand side would be of lower index than 2, and all the books on the right hand side would be of higher index than 2. Okay, as this is not my answer, I can basically split these books from 2 plus 1 to the last book, okay, and what is my last book in this case? 3. So this can be my starting and then this can be my ending index, okay. So what I'll do is I'll simply remove these from the pictures. Okay, I'll simply remove this from the picture. So these two books are removed. Okay, and now my starting point is where? Now my starting point is only here. I'm just left with only one book. Now I'll check for this book number. Maybe this is also not the answer we are looking for. So I'll check its number. Is it equal to my third book that I was looking for? Yes. So I'll return its index. I'll return this book to the person. Okay. I'll return this book to the person. Okay. So just try to think it like that. Like if you go in a library and you want to find a book with a particular number, so there can be many number of books stacked. Okay, so what your first choice would be? You would pick any random book, and you will check its index. Like you will check its title, right? You'll check its title. If the title is matching or the number is matching that you are looking for, you will just pick it up, right? You will just pick it up. And if you know that the book you are looking for can be on the left or right hand side, okay, based on the conditions. Basically, if this has an index 4 and you are looking for something like index 2, so this has to be on the left hand side. Because the books are sorted. Okay, and if you are looking for the index 6, so basically it has to be on the right hand side. Why? It has to be on the right hand side. Why? Because the books are sorted. Okay, so this is what we are working upon. Basically, instead of randomly choosing an array, instead of randomly choosing an index, we are always choosing the middle index. And if that middle index value is our answer, we will just return it. Okay, and if that middle index is not our answer, we'll just check on the left hand side of the middle index, that is mid minus 1, or we'll check on the right hand side, that is mid plus 1. From mid plus 1 to the last, or from 0 to mid minus 1, because I know that now it can lie only in this range. Okay, because mid is not my answer. So either my answer can be found in the mid plus 1 or mid minus 1 range, 0 to mid minus 1 or mid plus 1 to the last. These can be the only two ranges that are possible. Okay, so if I just go on to the right hand side, I'll do the same thing again. Okay, for these indexes also, for the right part also, I'll again choose some middle index. Okay, and if this is my answer, I'll simply return it, or I'll again split it into two parts, 0 to mid minus 1, or mid plus 1 to n. Okay, why we are doing mid minus 1? Basically, why we are doing mid minus 1 and mid plus 1? Okay, because now I know after comparing the value at mid, now I know that mid cannot be my answer. So why to include it? I am just excluding it in this and excluding it in this. Okay, so 0 to mid minus 1 can be my answer, is the range that has my answer, or mid plus 1 to n, maybe it has my answer, maybe it has my answer. Okay, so I'll just try to take a test case and tell you. If I just try to summarize what what is done in my binary search, what is done in my binary search, basically my middle element will be calculated, middle element will be calculated, middle element will be calculated, middle index will be calculated, and the middle element will be compared with the target, middle element would be compared with the target. If it is equal, I'll simply return the index, okay. And if it is not equal, there can be two cases, either my middle element, can be less than the target value, or my middle element can be greater than the target value, So in this case, if I get the first case, I'll simply return it, I'll simply return the index. But what if my middle element is less than the target? Basically, if suppose this is your array, and you get the middle element as this, and your target is 4, Okay, in this case, your target 4. This case, your target in your target 4 is greater than 3. So where can you find the answer? Can you find it on the left hand side, or can you find it on the right hand side? As the array is sorted, I can obviously find it on the right hand side. So what I'll do is I'll simply change my starting pointer to this index, because this array will be a waste for me. This array is now a waste for me. So my starting index would be this, and the same process would be repeated. What it will be done is s plus e by 2. What is my s and what is my e? Basically, this is the starting index and this is the ending index. Okay, and this process would be repeated. So if middle element is less than the target, what I'll do is my starting pointer would be equal to mid plus 1. Okay, and if my middle element is less than the target, my ending element would be equal to end is equal to mid minus 1. Okay, end is equal to mid minus 1. Okay, how similarly, if I take the same test case and my target is 2, so if this is my middle element, and my target is 2, where can I find my 2? On the left hand side or on the right hand side? On the left hand side, obviously. Okay, so I'll make this ending at as mid minus 1, and my starting would remain same. Okay, so these are the rules that I have to follow. These are the three rules that I have to follow for binary search to work. Why I'm not choosing the middle element? Why I'm doing mid minus 1 and mid plus 1 and not choosing the middle element? Because middle element is already disregarded, right? Middle element is obviously not equal. So what is the point of taking it again? I'll just exclude it. Okay. So if I just try to take a test case, 1, 2, 3, basically not 1, 2, 3, 5, 6, 9, 10, 13. Okay, and my target is gonna be 10. This is my array, and these are my indexes. Okay, so what I'll do for the first case, what I'll do is I put my starting pointer here, my ending pointer here, and for every pass I'll calculate my middle element. How can I calculate my middle element? Start plus end by 2. This is how you find the mean, right? Okay, so start plus end by 2, so it becomes 0 plus 4 by 2. This becomes 2. So my second index has my middle element, and what is my second index? 9. So my middle is pointing here. For this case, my middle is pointing here. Okay, so and what is my target? My target is 10. So which case are we fulfilling? My target is greater than my mid value. Target is greater than my mid value. So what I'll do is if target is greater than my mid value, start is equal to mid plus 1. Start is equal to mid plus 1. So my starting pointer would come from here to here. So my starting pointer would come here. Okay, and if my starting point is here, this whole array is disregarded. This whole array is disregarded. Why? Because now I can't find my answer here. Now I can't find my answer here at any cost. Okay, so these indexes are disregarded. Disregarded. Okay, disregarded. I'm just left with this 10 and 13. Okay, I'm just left with it with this 10 and 13. I'll again try to calculate. So my starting indexes are 3 and 4. 3 and 4. It becomes 3 plus 4 by 2. 3 plus 4 by 2. That means 7 by 2. That is approximately 3.5. So we take the floor of it. My middle value becomes 3. Middle value becomes 3. So my 3 becomes, middle value becomes 3. And what is that third index? 10. Yes, 10 is at my third index. I'll compare it with my target. Is it equal? Yes, it is equal. Okay, so I'll simply return it. So in this case, what my answer is basically 3. Answer is 3. Okay, answer is 3. If I just try to take one more test case, Test cases that are given basically -1, 0, 3, 5, 9, 12. -1, 0, 3, 5, 9, 12. -1, 0, 3, 5, 9, and 12. And what is my target? My target is 9. Target is 9. Okay. My starting pointer is here. My ending pointer is here. Okay. What I have to do for the first step? I have to calculate my middle element. So how will I calculate? S plus E by 2. Okay. So it would become, if these are my indexes 0, 1, 2, 3, 4, 5. Okay. This is my array and these are my indexes. Okay. How can I calculate? Basically 5 plus 0 by 2. So it becomes 2 because 2.5 and floor of 2.5, so basically 2. So my middle element is here. Okay, and is my middle element equal to my target? Is 3 equal to target? No. Okay, so can I compare this? My target is currently greater than 3. So what case I will follow? This case, target is greater than my middle element, so my start would become mid plus 1. Mid plus 1. So my start would be pointing from here to here. Okay, my start would come here, and all these elements would be disregarded. Why? Because now I can't find my answer here. I'm left with only 3 elements. Okay, and my start and end is updated. So if I again try to find out the middle element, start and end is updated. So it will become 3 plus 5 by 2. That is 8 by 2, and that is 4. So 4 contains my middle element. This is my middle element. I'll compare it to my target. Is it equal? Yes, it is equal. So basically fourth index, and that contains 9 value. 9 is equal to 9. So I can basically return this index. So 4 would be returned. Okay, so this is my answer. Okay, as you can see, what we are doing is basically we are calculating the middle value. Calculating the middle value. If it is the answer, I am basically returning the index. And if it is not the answer, I'll compare it with my target value. If my target value is greater than middle value, that means I have to go to the right hand side. Because if I am here and my target value is here, I have to basically consider the right hand side only, right? Middle is here, target is here, I have to consider the right hand side only, right? So I have to go to the right hand side. My start would come at the start would be updated. Start would come at mid plus 1. Okay, if the reverse is there, like target is less than middle value, so my end would be like mid minus 1. N would be like middle minus 1. Okay, N would be middle minus 1. So this is the case I am following. Now I consider a case where the number is not present in the array. Okay, minus 1, 0, 3, 5, 9, 12. 3, 5, 9 and 12. Okay, and I'll mark indexes 0, 1, 2, 3, 4 and 5. My target is 2. Okay, what is my first step? I'll just choose my starting and ending index. This is my starting index, this is my ending index. For the first pass, what I'll do is I'll calculate my middle element. How I can calculate? Start plus end by 2. Start plus end by 2. So starting index is 0, ending index is 5, it becomes 2. So my middle comes here, middle comes here, middle comes here. Okay, middle comes here. Okay, middle comes here. I'll just compare it with my target. Is it equal? No, no. So but what case I am following? Basically my target is greater than my middle value. Target is greater than my middle value. So if target is greater, is less than my middle value, basically target is less than my middle value. So what I'll do is, if target is less than my middle value, basically if my middle value is right here and my target is here, so what I'll have to do, I'll have to consider the left case. So for the left case, what I'll do is I'll update my ending index to mid minus 1. Mid minus 1. Okay, so my ending index would like get it from here, my ending index would get it from here, and it would come here, and it would come here. Okay, and all these array indexes would be disregarded. Okay, now my ending index is at like position this. Okay, at this position, I'll again calculate start plus end by 2, start plus end by 2. Okay, 0 plus 1 by 2, basically it comes as 0, okay. So I come to 0, this is my middle element. I compare this with my target. Is it equal? No, but my target is currently greater than my middle element. So what will I do is my start would increase, and how would my start increase? Mid plus 1. Okay, so in this case, my middle is here, okay, and my starting point is here. So my starting pointer would be incremented. My starting pointer now would be pointing at this place, okay. My starting pointer would be pointing at this place. So my ending and starting pointer are pointing at the same position, I'll consider one more case. I'll calculate the middle element, s plus e by 2. So it becomes 1 plus 1 by 2, it becomes 1. Okay, so this is my middle element also. Now is it equal to my target? No, but my target is greater than my middle element. So if my target is greater, if my target is on the right hand side, I have to choose the right hand side. So my starting would become mid plus 1. So my starting would be at the second position. Starting would be at the second position. Basically, minus 1, 0, and this is a 0 index, first index and second index. Okay. So my starting is at this position and my ending at this position. So in this case, my starting pointer has overcome the ending pointer. So this is what I have to stop at. Okay. So this was the overall approach to the question. Now I'll try to code it. Okay. What I need first, I'll need a starting index that is pointing to 0, and I need an ending index that will point to the last element, and what is my ending condition? My start should be less than equal to end. If and what was my first step? I was calculating the middle element. And how can I calculate my middle element? Start plus end by 2. Okay, now what I'll do, I'll just compare the middle value with my target. If it is equal, I'll return the middle element. Okay, else if the target value is greater than the middle element, that means it is on the right hand side. And if it is on the right hand side, what I'll do is I'll increase my starting pointer to what? Mid plus 1. And if my middle element is greater than the target, that is my target is less, that is on the left hand side, so I have to also go on the left hand side. I have to also go on the left hand side. How can I go on the left hand side? Yes, end is equal to middle minus 1. And if all of these conditions fails, like if my ending pointer, if my ending point is here and my starting point is here, basically not this, if my ending point is here and my starting point is here, basically my starting pointer, if it is overcome the ending pointer, if it has overcome the ending pointer, this is the condition that I stop. So if this condition has been followed, so I'll simply return minus 1. I'll simply return minus 1. Okay, I'll simply return minus 1. So at the last, what I'll do is I'll simply return minus 1. I'll try to run it. Not target dot size, nums dot size. Okay. Okay, I'll try to submit. So submitted successfully. Okay. So if I just try to go through the solution, what I'll do is I first place the starting and ending point at the start and end respectively. Okay, I calculated the middle index and I compared my middle index with my target. If my middle value is equal to the target, I'll simply return the middle index. If it is lying on the left hand side, I have to go on the left hand side. If it is lying on the right hand side, I have to go to the right hand side. Okay, how I have to go? If my target is on the right hand side, I have to increase my start pointer. If my target on the left hand side, I have to decrease my increasing pointer, end pointer. Okay, so if I just try to analyze the time complexity of this solution, if you see, your array size was initially n. Okay, and whenever you do one step, you reduce the size by half. Basically, if you are given with this, okay, and your middle value is right here, you have to look for the 4. Okay, so what you will do is you will basically split the array into half. You will basically split the array into half. These indexes would be ignored. Okay, so every time the size of the array is reducing by half, so n, that goes to n by 4, that goes to n by 8, and like this goes to 1. Okay, so if you try to add all this, you will get something like n by 2k, you will get something like n by 2k, and it will go like n equal to 2 raised to power k. If you take log on both sides, log n is equal to 2 raised to power k. Okay, log is equal to log 2 raised to power k. Okay, k log n. Okay, so k is equal to log n by log 2. K is equal to log n by log 2, and 2 comes here, 2 comes here, so the time complexity becomes k equal to log of 2n, log of 2n. Okay, log n base to power 2, log n to base 2. Okay, so this is my time complexity. Now I have derived also my time complexity. Okay, so time complexity for this case is O of log n, as we are dividing the array always by half. Okay, what is the space complexity? Am I using any extra space? No. What is my space complexity? My space complexity becomes O of 1. So this was the overall solution to the question binary search. Basically, question, like, it is a concept that you have to use again and again. There are many questions related to this. Okay, so this was the overall solution. If you have any doubts, you can just ping it out in the comments. If you like the solution, do like, share, subscribe. Thank you. Have a nice day. Bye bye.